Good morning, dear students. Today we will start with subsets, and let us check out the definition first. A set A is said to be a subset of a set B if every element of A is also an element of B. A set A is said to be subset of set B if every element of set A is also an element of set B. That means what? Consider the set X is a set of all students in your school, set of all students in your school, and consider set Y as set of all students in your class. So by taking these two sets, you will come to know that the set of all students in your class, and also you are the students in your school. So basically Y is subset of X. Symbolically it is represented by this symbol, or in other words, if I say, if I'll consider set A, that is a subset of B, then whenever A belongs to A belongs to A, then A also will belongs to, or A is an element of B, definitely we can say. And some more symbols we are going to use. This symbol is for a subset excuse me. This is for belongs to, this is also for belongs to, and one more symbol. This symbol is known as, or which means implies. Definitely we are going to use these symbols very frequently whenever we require. We can write the definition of subset as follows. A is a subset of B if A belongs to A, and that implies A belongs to B. The above, or this statement is read as A is a subset of B if A is an element of A, implies that A is also an element of B. So it is going to read like that only. And whenever we found that A is not a subset of B, then we will write like this. It shows that A is not a subset of B. This symbol is, I'll write here, not subset. this symbol is for not subset, and this symbol is for subset. And also we will encounter one more symbol. This is two-way implications, and it is usually read as if and only if. Let us have if A is a subset of B and B is a subset of A. If and only if A is equal to B. This is if and only if. This symbol means if and only means if and only if, and it is two-way implication. So we can read this as A is a subset of B and B is a subset of A, and if and only if A is equal to B. That means what? If A is equal to B, that we have studied in the last class or previous class, that if all the elements of A is present in the set B and only that much elements present in B, then only we will say that A is equal to B. So here we can say, and looking to these all those things, we can also conclude that A is a subset of A, or I can say that a set is a subset of itself only. And one more thing, this is a null set or phi. This is also one of the subset of the set A. So looking into it, we'll move further. And if I'll take an example, let us say set A is equal to 1, 3, 5, or I say the odd numbers less than 6, and if I say set B equal to 1, 2, 3, 4, 5 and 6, natural number up to 6. If I write natural number less than or equal to 6, then I'll get set B, and odd numbers less than or equal to 6 is 1, 3 and 5. So by looking into these two sets, I can infer that A is a subset of B, as I can represent 1 is here, 1 is also here, 3 is present here, 3 is also present here, 5 is there, 5 is also there. So all the elements are all the elements which is belongs to A is also present in B, or that also belongs to B. That's why A is a subset of B. You can conclude this one. And also this is known as proper subset, and B, this is a proper subset, and B is known as super subset. Here B is super subset. If A has one element, if A has one element, then it is also known as singleton set. Why? Because there is only a single element is there, that's why it is known as singleton set. So we can infer that also. Now we will move to the next point, that is we'll see set of real numbers, subset of set of real numbers. So we know that the set of natural number is given as 1, 2, 3, 4, 5 and so on. Set of integers. In this chapter we are using integer as symbolically we will present by z, and sometimes it is also presented as capital letter I. So do not confuse over here. Integer can be represented by capital letter Z and I both. So we are using here Z. So integers can be represented as, let us say, -3, -2, -1, 0, 1, 2, 3 and so on. So basically from -infinite to +infinite the numbers it will conclude. And set of rational numbers, it is represented as x such that x equals to p by q, where p and q belongs to integers and q is not equals to 0 or not equals 0. Q is not 0. So this is the definition of rational number we have or you have studied in class 9 and 10. Then real number. Real number is whatever number you can think of that comes in real number only. For now. And another one is irrational number. If we talk about rational number, then also we will talk about irrational number. This is the number x such that x belongs to real number and x is not q. Not q means not rational number. The real number which is not rational number is irrational number. Basically there are two things, rational number or irrational number, and these two includes the entire number system in real number. We will see a complex number over there also in the later on chapter. We have one chapter called complex number and quadratic equations, where there we will see some more number system, that is complex number system, and we will see that the complex number system is the biggest number system we have, and one part is real number and another part is complex number, that is a part of complex number, that is imaginary number. So these two includes and will make that complex number. So till now I'll discuss here only. For example, t is, I can write √2, √5, pi, etc. I should not write etc. over here. So likewise these are the members of, better you can understand, these are the irrational number, how it will work. We will see now how it can be written as. So subsets are, say, natural number is a subset of integers, as we can see 1 2 3 4 5, and this is starting from minus infinite to and going to plus infinite, and in between we can find 1 2 3 and so on. The same thing we are approaching over here. So n is a subset of z, and z is a subset of q. How? Definitely we are getting over here, for example, we can write minus 5, this is also a rational number. Minus 3 by 2, this is also a rational number. If we talk about 7 by 3, this is also a rational number. If we talk about 9, this is also a rational number. So these things are rational numbers. So these also include the integers. This also include integers, as we can write minus 5 by 1, 9 by 1. Likewise, we can represent in the form of p by q, and p and q are integers. So basically, we can conclude over here that z is a subset of q, that is, integer is a subset of rational number, and rational number is a subset of real number. Real number means the number which you can express in number line, that is known as real number. And that means we can also conclude over here that n is a subset of q, and also n is a subset of real number. This is one, this is second, this is third point, and what we can conclude over here is z is a subset of q and subset of r, so also it will be r. Z, that is integer, is also a subset of real number, we can conclude over here. And let us see this t. So the fifth point we can see t is also subset of r, and we can see as n is not a subset of t. This is a natural number. Natural number cannot be irrational number. So therefore, this is not a subset of irrational number. Natural number is not a. So these things we understood very well, and it is represented. Irrational number is represented by capital letter T. So we can understand these things, how a subset works. Now we'll talk about the intervals as a subset of R. So how we are going to define, we'll see that. Okay, so let a b belongs to real number, and also we are defining that a is less than b. Then set of numbers y such that a is less than y and y is less than b is called an open interval, and denoted by a comma b. All the, it means what? this is nothing but the y exists between a and b, a and b, between a and b, but not a, b. That means y belongs to between a and b, but a and b are not belong to that particular interval. Why? Because so this y is greater than a and less than b. So basically there are uh, four situation we have to show the interval, and that interval is, let us say the number is y and interval is a b. So y can be represented as like this, a, between a and b. Y can be represented as a and b, where a and b are included. Y is represented between a and b, such that y can carry the value a as one of its value, and it cannot going to be carry that value b. And another one is y is in between a and b, such that it is greater than a but less than or equal to b. That means it can include the value b. So if we, these are the intervals, the four types of intervals uh, we have seen over here, will represent by bracket also. So this is known as open bracket, this is known as close bracket, it is known as open bracket basically, but this is a close on one side and open on another side. This is also known as open bracket a comma b. So here we can understand that a and b are not included to the interval, but between a and b every number includes y. Here we can understood that a and b both are included, and in between the values, whatever the numbers we are getting, that is also